A glass of water. An ordinary thing most of us take for granted. But here is another kind of water, and that is the bow of an atomic submarine, which is capable of staying submerged for weeks, even months. On such an underwater voyage, the submarine's personnel consume about 8,000 gallons of fresh water each day. Obviously, a submarine cannot store that amount of fresh water. It must manufacture it. Last month, the Navy and Interior Departments announced the award of a contract to the General Electric Company for the further development of a new method of converting salt water to fresh water. Today, we're in room 664 on the 6th floor of the General Engineering Laboratory, where this new process of distillation is being further developed by Dr. Franz Neugebauer and Mr. Edward Lustenader. Dr. Neugebauer, Mr. Lustenader, I understand that you've been working on this distillation process, which you call thin film distillation, since 1954.
Actually, the basic ideas were conceived in 1955. After the U.S. Navy showed some positive interest, we have a concrete goal, and we started to build this equipment in the spring of 1959.
There are methods of distillation in use, aren't there?
Of course, there are other methods of distillation. They are in use, and other companies are engaged in development of water stills too.
Just what's involved in distilling pure water from seawater, Ed?
Well, seawater contains about 35 pounds per 1,000 pounds of water. City water, on the other hand, such as Schenectady water, contains less than 1 pound of dissolved solids in 1,000 pounds of water. These dissolved solids are mostly salt. Any distillation apparatus such as we have here is required to remove these solids from the seawater.
Doesn't sound so simple to me.
I'm quite sure it's more complicated than that.
Oh, it certainly is.
So this is the apparatus you developed.
Yes, this is the distilling unit that we have built. Let me show you a cross-section of it. This is a cross-section of the distilling unit. It consists of a circular tube. This is the heat transfer surface. The tube is surrounded by a concentric steam jacket to which waste steam is supplied for heating. Inside of the tube is a rotating wiper assembly driven by an electric motor. Seawater flows up through the hollow wiper shaft to a distributor. The distributor brings the water out to the wall at the top of the tube, and this water is then distributed just ahead of the rotating wiper blades. As the wiper rotates, the seawater is spread as a thin film on the inner surface of the cylinder. The surplus seawater then flows ahead of the wiper blades and is taken out as the base of the unit as a brine. As the thin film of seawater evaporates, this vapor is then drawn off to a distilling condenser where it is condensed out and can be used for drinking.
Doctor, is this process fully developed yet?
Not yet. We are now in the middle of the development.
Yes, in about a few weeks, we plan to operate this equipment on natural seawater, and this will be trucked in at a rate of about 3,000 gallons a day from Rockport, Massachusetts, and we'll pump this from the parking lot up here to our installation and run it through the equipment.
Doctor, so far we've been talking about naval applications. Are there others?
There are other applications. The Army is interested in portable equipment. Municipalities need more and more fresh water. Civil defense is stockpiling units, and the chemical industry is interested in stills for liquids other than water.
Gentlemen, thanks very much for being with us today.
It's been a pleasure.
Schenectady General Electric continues daily to devote a great deal of effort to research and development of new and better products and processes, like making fresh water from seawater. Another example of the progress that makes Schenectady and the name General Electric synonymous with technical and scientific achievements.